This is a video to locate intervals where a function is increasing or decreasing. The question states, identify the open intervals where f of x is increasing or decreasing. F of x equals x plus 9 over x. There's a theorem that states that a function is increasing when its derivative is positive, and it's decreasing when its derivative is negative. So we're going to find out when the derivative is neither positive nor negative. So that means it's either 0 or undefined. So let's take the derivative of f of x. And when I do that, the derivative of x is 1. I can write 9 over x as 9 times x to the negative first power, and its derivative will be negative 9 times x to the negative second, or minus 9 over x squared. So there's my derivative. Let's set that equal to 0 and solve. So multiply by x squared on both sides, and I get x squared minus 9 equals 0. And that has solution x equals negative 3, or x equals 3. But we're not done yet, because a critical point also occurs when the derivative is undefined. Notice that when x equals 0, f prime is undefined. And in fact, f of x is not continuous at 0. So of course, f prime is not defined. So we add our third value of x equals 0. So now let's draw a table. And on my table, I'm going to put intervals from negative infinity until I get to my first critical point, which is negative 3. Then negative 3 to my next critical point, which is 0. Then 0 to my next critical point, which is 3. And then finally 3 to infinity. And what I want to do is I want to put in some test values. I could put in any number in the interval. I will put in negative 4, because that's between negative infinity and negative 3 for the first interval. Negative 1 for the second. 1 is certainly between 0 and 3 for the third. And 4 for the fourth test value. And the way we use test values is we plug that value into the derivative and decide whether the sign of that derivative is positive or negative. So for example, if I plug in negative 4, I get 1 minus 9 over 16, and that's a positive number. If I plug in negative 1, I get 1 minus 9 over 1 squared, which is negative 8, so that's a negative number. Similarly, if I plug in 1, I get negative 8, which is a negative number. And if I plug in 4, I get again 1 minus 9 over 16, and that's a positive number. So I can make conclusions now, because the theorem says that if the derivative is positive, it's increasing. So I'm going to say it's increasing in this first interval from negative infinity to negative 3. Here, between negative 3 and 0, the derivative is negative, so it's decreasing in the interval from negative 3 to 0. It's also negative between 0 and 3, so the function is decreasing between 0 and 3. And the sign of f prime is positive between 3 and infinity, so f is increasing between 3 and infinity. And I'm done with the problem.